Hi, this video is about multiple linear regression, and I'm going to show you how to solve the problem using Excel. And let's go back to the problem. We have the Butler Trucking Company. Let me show you here the Butler Trucking Company, and we have the total travel time that depends on deliveries and miles traveled. Okay, so we're gonna use data analysis tool like we did before to solving for the estimates that we're looking for. Okay. So let me show you how to do that. Let's open Excel. So here's the Excel file Butler, okay? And here the assignments, the miles, the delivery time, the deliveries, and the total travel time. So we go to data analysis, and then we go to regression, okay? Input Y range. So input Y range, time is our dependent variable, is our Y variable. And now we have to input the X variable, so we select both together, so both columns. And then we check labels because we're selecting the labels in the first row. And then we have to tell Excel that we have the first row is labels. We can leave the output as a new worksheet. And let's ask for residuals, standardized residuals, and residual plots, because remember we had analysis of residuals in our chapter 14. So here's the data. I'm going to skip this residual analysis for now. So let's take a look at the coefficients. That's what I want to highlight right now. So in order to make everything easier to understand, I'm going to reduce the number of decimal places in these cells. And to do this, I select all these cells, I go to home, I look for here in the number, look for these decimal places, and I'm going to reduce to make them easier to visualize. So here you see that we have the intercept, we have the coefficient associated with miles, and we have the coefficient associated with deliveries. So let's go back to our problem, and remember we have Y B0 is our intercept. So I'm going to open a column here to help you coefficients. So let's say B0. This is okay, so this is B0 because this is the intercept. There is no variable associated with this coefficient here. You see, no variable, is only the coefficient. So this is our beta 0 coefficient, okay? So this is the beta 0. So let me do this, beta 0. So this one is x1 is our miles traveled. So the coefficient, so miles traveled I have here. So the coefficient associated with miles traveled is beta 1 or B1. So B1, this is B1, our coefficient B1. And if we take a look here, x2 is deliveries made. So B2 is associated with deliveries. So we have deliveries here. So we know that these are the coefficients, okay? Let me centralize these cells. I click here and again. I think that's easier to see, okay? So these are the coefficients. So if I have to write the regression equation, what I have is total time, or Y, is equal to B0. B0 is negative 0.869 plus 0.061, this coefficient here, multiplied by miles plus the other coefficient 0.923 multiplied by deliveries. So this is our regression equation with the coefficients, okay? So here is the same thing, negative 0.869. In this case, we have only one decimal place. They have one decimal place more. They have 4, we have 3. Plus 0.061 x1, miles 1. So that's the same thing. If I want to predict, let's say I want to predict what's going to be the total time. Let's say if I have an assignment in which the miles is, let's say, 80 miles and deliveries are 3 deliveries, okay? So the predicted total time is going to be equal to this coefficient, okay? So let me do that. So the predicted total time is going to be equal to negative 0.869 plus, I'm going to open parentheses, 0.061 multiplied by the miles, 80 miles, close parentheses, plus 0.923, open parentheses, 0.923 multiplied by the number of deliveries. So the predicted total time is going to be 6 hours and 78 minutes. How do I know that is hours? Because if I go back here, I have, as my data set is established as hours, okay? So I know that if I give an assignment to a truck driver and the assignment has 80 miles and 3 deliveries, I know that the predicted total time is going to be 6.78 considering these coefficients, okay? So this is how you use this information to predict what's going to happen in the future based on information that you have in the past, okay? Now let's interpret these coefficients. What's the interpretation for these coefficients, okay? So let's take a look at interpreting coefficients, B1. Let me see if I have all them. I think I do. No, let's take a look at this first one. I don't have on slides, but let me interpret this one. Okay, so what does coefficient mean? So let me put here. B0 means that the total travel time, the average, because the intercept is the average, total time is negative 0.0869 hours if the assignment has 0 miles and 0 deliveries. I want to use this example to show you that sometimes the intercept or the B0 doesn't have like a real mean, because you cannot have negative hours. But in the context of using other variables, you need this negative coefficient to make the prediction meaningful, okay? So the key takeaway is sometimes B0 is not meaningful, okay? Sometimes it is meaningful, sometimes it is not. In this case, it is not, because there is no assignment of travel if you don't have miles and if you don't have deliveries, okay? Now let's take a look at B1, what B1 means. Let me interpret that and then I take a look at the slides later. So B1 means that for each additional mile traveled, the total time increases by 0.061 hours. Oops. So always this coefficient means that if I increase 1 unit of the independent variable, this is how much the dependent variable changes. Okay, I'm going to repeat again. This coefficient means that for each additional unit in this independent variable miles, for each additional mile travel, the dependent variable total travel time in hours is going to change by 0.061. This is what I said here, okay? Let's take a look at slides. 0.0611 is an estimate of the expected increase in travel time corresponding to an increase of 1 mile in the distance traveled when the number of deliveries is held constant. Okay, so the only thing missing for me here is B1 means that for each additional mile traveled, the total time increases by 0.061 hours, holding constant the number of deliveries, which is the other independent variable. Okay, so what happens is when we interpret one of these coefficients, we always assume that the other variables are not changing. They are held constant. Okay, that's the main assumption in the interpretation. Okay, so let's interpret B2. B2 means that for each additional unit of which variable? For each additional unit of deliveries, for each additional delivery, what increases? The dependent variable. The dependent variable is the total time. The total time increases or decreases? Increases because this coefficient is positive. So total time increases. By how much? 0.923 hours. Holding constant. The other variables, constant. The number of miles. Okay, so this is the interpretation. Let's take a look at the other one. This is B2. B2, 0.9234 is an estimate of the expected increase in travel time. The total time increases by corresponding to an increase of 1 delivery when the number of miles traveled is held constant. Okay, so this is the interpretations. Again, to summarize, for each additional unit in this independent variable, this is how much the dependent variable increases, holding constant the other variables in the model. Okay, so let's take a look at the coefficient of determination. Remember, the coefficient of determination is how much the r squared, that's the coefficient of determination. Let me reduce the number of decimal places. So this is the coefficient of determination. This is how much the dependent variable is explained by the independent variables in our model. Okay, so let me move this to here. Let me interpret. But before I interpret, I want to call attention for the adjusted r square. The adjusted r square is the one that we're going to be using in multiple regression because it adjusts for the number of independent variables. So this is adjusted coefficient of determination. So what's the interpretation here? The interpretation is the variance in the total travel time, which is our y variable, is explained. So the variance, I'm sorry, the 87.8763 is this. 87.63%, which comes from here, of the variance in total travel time is explained by the variance in the independent variables. I have to list them all. In the variance of miles and deliveries. Okay, that's the interpretation. 87.63% of the variance in total travel time is explained by the variance in the variance of miles and deliveries, which is our independent variables. Okay, so this is what it's saying. The adjusted multiple coefficient of determination compensates for the number of independent variables in the model. Okay, so I'm going to stop here and prepare another video about interpreting the F test, the ANOVA, and the test of significance.